Hey there, and welcome to the channel. In this video, I'm going to be showing you something that I built after watching Adrian's Digital Basement video yesterday on a brand new game for the Apple Lisa. In that video, if you go check it out, I'll link it in the description. It shows a new game that somebody wrote for the Apple Lisa, and it's the Minesweeper game. And it made me starting to think, like, why is it that we got stuck with text-based operating systems for such a long time in the in the Intel space, and the Apple Lisa was able to build this seemingly, it was still slow but usable graphical UI with a machine that ran at 5 megahertz, similar to the 4.77 megahertz 8088. Now, the 68,000 did have a 32-bit address bus internally, which may have helped it a lot. And externally, it was a 16-bit CPU. So last night, I started to look at the comparison between the Motorola 68,000 and the x86 CPUs and trying to see, okay, there's the 68,000 running at 5 megahertz. What would be the comparable CPU to that one? Because I wanted to see if I could build quickly with AI an operating system similar to the Mac OS that I could run on a real Intel XT class machine. And I did some research, and according to ChatGPT, the 8086 is the most accurate historical counterpart. It arrived at the same time and also has a 16-bit external data bus. The Lisa 68,000, like I mentioned, did offer a 32-bit registers, and a much larger flat address space and a much cleaner programming model. The 286 and the 386 CPUs are later generations and are more capable, as we all know. But if you take a look at this table here, you see that the Apple Lisa CPU ran at 5 megahertz. It had 32-bit data and address registers with an external 16-bit bus and a 24-bit physical address bus. It supported up to 16 megabytes of RAM, and it had a flat linear address space, and Lisa added its own MMU. So comparing that one, let's see here, the 8088 that ran at 4.77 megahertz. It has 16-bit registers and arithmetic, which it's already weaker there. It's got an 8-bit external data bus, so it's much weaker there. And it's got 20 bits, so it can support up to 1 megabyte of RAM and segmented addressing. Its narrow bus usually gives a lower memory throughput, absolutely. So I don't want to, we can make the operating system work here. It's just not going to be that fun to use, I don't think, because writing to graphics with an 8-bit bus is going to be painful. Now, the 8086, the early 16-bit x86 systems, this ones you can run from between 5 to 10 megahertz, so it would be kind of cool if I could get one of these running at 5 megahertz and compare it to the 68,000. Now, whereas weak, it's 16-bit registers, so maybe because I have to do twice the amount of work to get one, data data block transfer. Let's just say, I know there's overhead in everything we do inside the CPU, but maybe a 10 megahertz 8086 could perform as close to a 68,000. It does have a 16-bit external bus as well, but it still has a 20-bit physical address bus, but the 68,000 still beats it. All right, let me see here. I don't know what I'm doing here with this video capture. Cool. Now let's keep on going here. The 286, these start getting a little bit more interesting. I initially thought the 286 would be the most comparable one, and in my head, honestly, that would be the most comparable one in terms of performance. It's still got a 16-bit registers, but it's got a protected mode added, and it runs much faster. So a much faster 286 could potentially show the same level of performance or even better than the 68,000 running a graphical UI. And it finally has 16 megabytes of addressable space and protected modes. So, and usually faster in complete systems. Yeah. So, and of course the 386SX is a faster. This one is also interesting. I thought, okay, it's either 286 or 386SX. Why? Because the SX has a 32-bit internal bus, and then the internals are still the external bus is 16-bit, and it supports now. It starts looking closer to what the 68,000 does here. And of course, the 386DX is 32-bit all around, and that's a whole different. It's going to be much faster than the 68,000 by a lot. All right. So what did I do? Now that I've said so much, I went ahead and I had a AI. In this case, I used Claude Fable, the latest model from Anthropic, and I had it built last night. It took an hour and a half to build JOP. It's going to be renamed to JOPS. Like, my name is Jorge. It's Jorge Operating System. I know, creative. I was bored, but this is what it looks like. It's going to be a Macintosh System, one style graphic operating system for the Intel 8086, written in real mode assembly and booted from a floppy. It's going to support 640 by 480 in 16 colors. So it does require a VGA card on your XT machine. So I did that because I wanted to look like the Mac, and the CGA is not gonna cut it. So I'm gonna go this route, and maybe I'll add CGA support later, but who knows? There's gonna be overlapping draggable windows, pull-down menus, and then the key feature that I wanted to have was pre-emptive multitasking, because the Mac was cooperative multitasking. As you see here, the real 1984 Mac never had. Now, I have it running in QEMU and in 86 box, and I'll show you that in a moment. And this is how it looks. It wrote 3 programs: the clock, a bouncing game, visual, and a notepad. And it boots straight into the GUI, similar to like what the Apples do. And this is how it was built. It has a VGA mode 12, 640 by 480, 16 planner. No back buffer because it doesn't fit in 256K of RAM, and I want to be able to run this in a video in a video upcoming soon on a real machine instead of 86 box, to see how it actually works when I actually try to use it. And then it has, like I said, preemptive multitasking. So that is something that I really wanted to have. Apparently it can run 4 tasks. Interesting. Maybe I'll increase that and see how that works. It supports Microsoft Serial Mouse. It's got keyboard support, obviously. It's got a font that it created, an 8x8 font. And it has concurrency for the drawing, Okay, so it's got some real usable things here. And I can create it, and it fits in a 360 kilobyte floppy disk image. All right, so what I'm gonna do now is I'm gonna switch over, and I am gonna show you how it runs. All right, so let me actually go ahead and close this off because I ruined the ta-da moment. Let me see here, force quit. All right. So what I'm going to do here is I'm going to go to the terminal, and I have the folder here, and I am going to make this open source after I'm done with some things that I want to add to it. So, and I want to see if I can make it possible for others to contribute. So what I'm going to do is I'm going to run it in 86 box because that's the most realistic hardware. All right, and hopefully this is getting recorded right. So as you see here, it's booting up a virtual 8086 based PC with 256 kilobytes of RAM and a 512 kilobyte video VGA video card. All right, it's loading. And I'm really curious if when I do run this on a real machine, if it's gonna perform this fast. Because to me, that was a really fast loader, and the graphics redraw really fast. So I am hoping that this actually works this well in an 86. But enough rambling. Let me show you what we have here. So we have an Apple menu, which I'm not happy that the AI used an Apple icon there, so I'm probably gonna have to change it to like a J or something. If you have a better name for this operating system, I'll take suggestions. But yeah, if I go to About Job, this is Job 1.0, a graphical OS for the 8086, preemptive multitasking with 640 by 480 and 16 colors. We have a file menu up here, which has Notepad, clock, bounds, and close window. So, but you can also close windows like this. And you have the Notepad, like I said, this one right here. So, hello, this is Jobs, the preemptive multitasking operating system for 8086 machines. And I'm trying to see if I can drag and resize windows. No, I can't. I can only drag them, not resize them. That's fine. I can add that feature. Now we have a clock. Notice how the clock, the bounds, the software, the dragging, everything is happening without stopping the machine. So it's true preemptive multitasking, at least for up to 4 tasks, as you saw there. So we'll see how far we can take that on real hardware. I want to be able to, I'm already actively making some changes to the code base as we speak here, and I'll show you that in a second. But yeah, I think this is pretty cool already. You have the bounds, you can close it out. You can close this, and I can hit restart, and it restarts the operating system. And everything loads up again. All right, so let's go back to what's next. So right now, I am adding a file manager. I am adding, so if I go here to workflows, all right, it's all these agents are running running right now, and in the next version of Jobs, which I'll show you in the next video, it's going to have file manager support, and floppy disk drive support, with a game, the Minesweeper game, that I asked it to use color in to showcase the loading of like Minesweeper and playing it, just like the one that was just showcased on Adrian's Digital Basement. So hopefully when this is done, as you can see here, it's almost done with 6 agents here, and it's verifying. I will be able to run Minesweeper with a file manager on a second floppy disk image that anybody can download, and load the operating system with one floppy, and then load software using the second floppy drive. So hopefully we'll get there, and I'll show you that in the next video. All right, I would love to hear your comments on this. This is like a fun little thing that with these AI tools now you can experiment and try out. As soon as I have more of this built and more instructions, I will publish this for as an open source project so that people can contribute, download, play with it, and also I will be releasing images as well, so that you can just download the images if you don't want to do any of that, and you can load the software on your own machine. All right, well, thanks for watching. I look forward to hearing about what you think in the comments. Thank you.